In this video, I'm going to show you guys how to make a 2D platformer movement in Unity using the new input system. Yes, I know the new input system is kind of complicated to use, but in this video, I'm going to show you guys how to utilize it on a 2D platformer character. So without further ado, let's get started. So here we are at an empty 2D scene, and the first thing you want to do is add two squares for both the player and the ground. Then, add a box collider 2D component to both squares and a rigid body 2D component to the player. Now if you press play, the player should fall down. Great. So now we need to find a way to move our player. In order to do so, the first thing you want to do is add a player input component onto our player. This component is used to detect player inputs provided by this input asset right here, which contains action maps, action, and binding for said action. Well, that's a mouthful. Now the player input has 4 different input behaviors, but for this video, we're gonna use invoke C# events. Because we're using this input behavior, we need to go to our input asset and click on generate C# class, and then click on apply. Once all of that is done, it's time to make the actual movement mechanic. So let's make a new mono behavior script and call it something like player movement, and double click it to open it in our script editor. First, we need to add a new namespace to use our new input system classes in this script. So let's type in using Unity engine.input system. Then we're gonna add a public input system underscore actions variable called actions. Then we're gonna add public float variables to adjust our player's speed and jump force, and another float called move to control the direction of our player's movement. And finally, we'll add a rigid body 2D variable called RB to control our player's physics properties. Now, since this rigid body 2D variable isn't public, we have to assign it through code. And to do so, inside our start method, we'll type in RB equal to getComponent rigid body 2D. This will automatically assign the variable using our player object's rigid body 2D component. Now we need to set up the new input system with this script. First, we need to make a new method called awake. This method is the same as start, but awake is called even if the script or the object attached with the script is disabled. Inside this method, we'll type in actions equal to new input system underscore actions. Since our input is disabled by default when playing the game, we have to enable it. And to do so, we need to add a new method called onEnable. This method will be called when the script attached to a game object is enabled. Inside this method, we'll type in actions.player.enable. This will enable an action map inside our action asset called player so that the actions inside said action map can be used inside this script. Once we enable the action map, we'll type in actions.player.movement.perform plus equals movement. Now what's happening here is that we go through the player action map and search for an action called move, detects if the action is performed, and then use that on a method called movement, which we'll be making later. And do the same thing with jumping mechanic by typing action.player.jump.performed plus equals jumping. Now we need to detect if the player input action is cancelled or released so that we won't perform an action indefinitely. And to do so, we're just gonna copy and paste these 2 lines and replace performed with cancel. Now we need a way to disable inputs when the script or the game object with this script is disabled. So we'll add a new method called onDisable. This does the exact opposite of onEnable. Well, as the name suggests. Now, since we're technically doing the same thing but disabling it instead, we can just copy and paste these 3 lines, replace the enable with disable, and replace the plus equals to minus equals. Simple as that. And that's how you set up the new input system with your mono behavior script. Now let's make our player move. First, we're gonna make a new method called movement. This method references the movement we put here. And since this line is expecting an input actions callback context from this method, we'll make a new parameter to this method. So let's type in input actions.callback context, and let's call it CTX, or context for short. Inside this method, we'll type in move equal to ctx.readValue vector2.x. Here, we read the vector2 value inside this context, being the move action, and take its x value since we only need a single float value. Then we're gonna make another method for our jumping mechanic. And inside this method, we're just gonna put the actual jumping mechanic. So let's type in rb.linearVelocityy equal to jump force. This will set the up velocity of our player to our jump force value for a single frame. Now inside our update method, we'll type in rb.linearVelocityx equal move times by speed. This will set our horizontal movement to our move value multiplied by speed. Let's go ahead and save this and go back to Unity, set both the speed and jump force like so, and hit play. As you can see, we can indeed move and jump? Hold on. Okay, so the jump action occurs when we press or release the button. My mistake. Let's go and fix it. Inside our jumping method, we'll add an if statement to determine whether we perform the input or not. And if we do, the jump action will occur. Now let's save this and see if it fixes anything. And it indeed does. The jump action doesn't occur twice when pressing a button. Great. Now we can move around with the A and D keys and jump around with the spacebar. But we're not stopping here. If you haven't noticed yet, the player can actually jump midair because we still don't have a way to detect if it's on ground or not. So let's go ahead and fix that. First, we need to add an empty game object called ground check and place it right under our player. Then inside our script, we're gonna add a few more public variables for the ground check transform, radius, and the ground layer. And also a private bool variable called isGrounded. Then inside our update method, we'll type in isGrounded equal to physics2d.overlapCircle groundcheck.position, groundcheckRadius, and ground layer. This will make an invisible circle at the ground check object's position, and if the circle overlaps with an object with a specific layer determined by the ground layer variable, the isGrounded bool will return true. Inside our jumping method, we'll make another if statement inside the if statement we have to determine if the grounded bool is true. If it is, then the player will be able to jump. This will prevent our player from jumping midair. And that's about it for ground checking. So let's save it and go back to Unity. Inside our player movement, we can now set the ground check object and radius. However, we can't really see how big the ground check radius is. So we need to find a way to visualize it in the scene view. So back in our script, we're gonna add a new method called onDrawGizmosSelected. Inside this method, we'll type in gizmos.color equal to color.red or whatever color you desire. Then we'll type in gizmos.drawWireSphere groundcheck.position, groundcheckRadius. This will draw a red wire sphere or any color you choose at the ground check's position whenever we select the player. And that's all we need to do for our player movement, so let's save it and go back to Unity. Now if we select the player and adjust its ground check radius, we can see a red circle appears indicating how big the ground check trigger is. Now I know this is technically a sphere, but we're seeing this in a 2D perspective, so it's a circle. For now, let's just set it to something like 0.1. Oh yeah, and also don't forget to disable the Z rotation on the player's rigid body, because we want to keep the ground check's position below the player. Once that's done, we're gonna make a new layer for our ground object. So let's go to this layer dropdown and add a layer. There's a bunch of empty fields here, but we're gonna be using this one and call it ground. Now we can go to our ground object and set the layer to ground, and inside our player movement component, we'll set the ground layer into, well, ground. So now if we hit play, you can see that even if we spam our spacebar, the player can't jump midair, which means the ground checking works. Cool. And there you go, a proper 2D platformer player controller with the new input system. Now before I end the video here, there's something cool I wanted to show you guys. Since we're using the new input system for our player movement, it's easier to perform inputs with other platforms such as console and mobile devices. Let me show you how. Let's start with mobile inputs. To make the mobile inputs, we need to add a canvas to our screen and set the scale mode to scale with screen size. Inside our canvas, we're gonna add a simple image and set the source image to knob. Then we're gonna add a component called onScreenStick to the image. Now if we hit play, we can move the joystick around but nothing seemed to be happening. To add an action, we're gonna go back to our onScreenStick component and select control path. Here, you can assign any input bindings that is a vector 2, like a gamepad joystick for example, which means that we're actually performing a gamepad stick input using our on-screen stick to move our player. Now if we hit play, we can now move around our player using the on-screen stick. But if you want to use buttons instead, it's doable. We just need to remove the on-screen stick component, duplicate the image, and add an on-screen button component to both images. The control path still works the same but for buttons. So let's just assign one for the A key and another for the D key. Now if you hit play, we can now move our player using either of the two buttons. Adding mobile input is as simple as that with the new input system. See, I can even make a jump button by just duplicating one of the existing buttons, move it to the right side, change the control path to space, and that's it, a jump button. Also, since we're using an action map that supports multiple devices built in, we can actually use our gamepads to move our player. Let me give you a demonstration. Okay, so here we are in real life. Okay, here we are in real life. As you can see, I have my scene here. Let's just press play for a second. Alright, there you go. So the scene is playing. I have my controller here. As you can see, if I move my left joystick, it works. And then if I... Gosh, I have to use my other hand for this. If I press the jump button, which is this button right here. If I press the jump button, it works. And as usual, if I spam click this, it won't fly away, which is cool. This also works with other controller, not just this. This works with other controllers like the PS4 controller, the Xbox controller, and I don't know, this thing I guess. And I guess that's it for this video. I hope you guys could understand everything and find this video helpful. And if you do, be sure to leave a like and subscribe to my channel. And yeah, see you guys on the next one.